Hi, Karibu. This is your teacher Raya from ElimuHubMaths. In this session, we're going to solve 3 questions on describing regions of inequalities. So let's start. So before we can describe regions of inequality then, I'll do a quick recap on what you need to know. So what we need to know is we have horizontal lines, we have vertical lines, and we have slanted lines. So these are lines that look like this. They have gradient. Like that, could be steeper. This is called positive gradient. This line has a negative gradient. This has a positive steeper gradient, and this one has similar to that one, but it could be steeper. That's still a negative gradient. Okay, so what do we need to know about these lines then? Where horizontal line is normally expressed as y equals something, some constant. So let's say y equals 4, y equals -3, and so on. Vertical lines take a form of x equals to some constant. So let's say x equals 7, x equals -10, and so on. So what about these slanted lines then? These are also straight lines, but they're slanted. So we must remember, if they're slanted, they have a gradient. They cross the y-axis at some point. That means they must be a y-intercept. We can have a negative gradient. We can have a positive gradient. We can have a positive intercept. We can have a negative y-intercept. We can also have an intercept where the line crosses through the origin. So c equals to 0 at that point. What else do we need to know? Well, if we have a dashed line, we need to use one of these inequality symbols. If we have a solid line, we need to include the equal bit. All right, here we have 2 lines. This one is easy, y equals 2. And this one is dashed, slanted line. So what do we need to know? We need to know m, we need to know c. What's the gradient of this line? Well, for every 2 of x is going up 2. It's positive, so it's a positive gradient. So y increase divided by change of x, 2 over 2 equals 1. So m equals 1. What about c? Where does this line crosses the y-axis? We're at 0, 0. So c is equal to 0. So the equation of this line then, y is equal to 1x plus 0. We don't write 1x, we just write x. And we leave the 0. But we are given this region here that's labeled R. So that means there are more than one solutions. This means for this line, the only region we want is going up that way. And for this line, we want this area that's going that way into this region. So that's when we need to use the inequality symbols. So for the first line, this line y equals 2, we need y greater or equal than 2. Why? Because we have a solid line and that way is greater than 2. So y greater or equal to 2 is our first line. Now for this region, for this line, we need to take one of the coordinates. The best way to do it is to take the coordinate on the axis. So we can take a coordinate on the x-axis or the y-axis. Well, I'm going to test this side of the line because that's the one I want. So I'm going to take this point. So I'm going to test point 4, 0. And my line is y equals to x. So I can see when x is 4, y is 0. If I go up here, x is 6, y is 0. If I go up here, x is 6, y is 4. So anywhere on this side of the line, y is going to be less than x. So for that one, y is less than x. Do we need the equal sign? No, because we have a dashed line. So that is question 1 done. Now for question 2 then, we have 2 lines again. So this line x equals, what's the number here? 2. It's a vertical line. For this line, what do we need? We need m, we need y-intercept. What's the y-intercept? That's an easy one to see. It's -4, so c is -4. What about our gradient? Well, try and take a clean line so I can see for every 2 of x is going up 4. So 4 here, 2 here. So m is going to be 4/2, which is 2. So m is equal to 2. I can see it's leaning this way. So the gradient is positive. You can also see in this direction the line goes up. Okay, so the name for this line then is y equals 2x take away 4. So now we need to look at our region. The region is this one here. So for x, we have a dashed line. That means we want this direction. And for this slanted line, we want this direction. Okay, so now let's test. Well, the first one is easy. So going in that direction, x is less than 2. And now for this one, we have y, 2x minus 4. I'm going to take a point to test which side is it going to be greater than or equal than. Now, because it's not going through the origin, I can always take the point of origin to test this line. So it's on this side of the line, which is what we want, because that's the region that's given there, R. Okay, so we're going to test this point 0, 0. So when y is 0, what do I get? 0. 2x times 0 is 0. Take away 4. I get a -4 on this side. So what do we say? Which one is bigger, 0 or -4? Well, 0 is bigger, so y is going to be greater than that one. Do we need the equal sign? Of course we do. It's a solid line, so we need to include it. So that's your solution for question 2. And now for the last question then, we have 3 lines and we are asked to describe this region here, label R. So again, we need to label each line. This line here is y equals, what's the gradient for this one? I can take this point here, is going up, is going 2 in the x direction and going 2 in the y direction. So the gradient is 1, so that's going to be x. And what is the y-intercept? Well, it's crossing the y-axis at -6. So this line is y equals x -6. So what about this line here then? Y is equal to, what's the gradient? Well, if I take maybe this point here, I can see 2 is going 2 that way in x direction and it's going down 1. So it's going down, that means it's going to be a negative gradient. So this is going to be -12 x. And where does it cross the y-axis? Well, it's this point here, which I can see is probably going to be 1. So it's -12 x plus 1 for this one then. And for the last line, y is equal to, what's the gradient for this one? Well, let's try and find a clean point. So here, we can see it's going 2 that way and it's going down 4. So 2 that way and going down 4. So gradient is -4/2, which is going to be -2x. And where does it cross the y-axis? It crosses the y-axis at -6. So this line is -2x, take away 6. And now what do we need to do? We need to test the lines. So let's just write them here, y, and then we have x, take away 6. So none of them are going through the origin, so we can use the point of origin to test these. So if we take point 0, 0 to test each one of the line, then that will tell us which is in the middle, which is the region that we need. Okay, so if we put 0 on this side, then what do we get? We get 0, take away 6, we get -6 on this side. Which one is bigger? Well, 0 is bigger, so this is going to be 0, y greater than x minus 6. So if we take this line, Do we need the equal bit? No, we don't, because it's a dashed line. So that is the answer for that one. Now let's take this one here. So we have y, and then let's just write it down first. Negative half x plus 1. If I take again point 0, 0, I get a 0 on this one. And then I get a 0 here. Negative half x times 0 is 0. So 0 on this side, and I get a 1 on this side. Which one is bigger? Or which one is smaller? Well, y is going to be the smaller one. So smaller, again, is a dashed line. So y is less than half x plus 1. Now for the last one, we have y. What do we put? Negative 2x. Take away 6. So again, we're going to test this region using 0, 0. I have 0 on this side. Negative 2 times 0 is 0. And then I'll have negative 6 on that side. So I'll have 0 here and I'll have negative 6. So 0 is bigger than negative 6. And now I have a solid line. So I must put the equal bit as well. So that is the answer, the solution for question 3. And thank you for watching. Please remember to like and subscribe, and see you again soon. Bye for now.